No, madam.
Yes, sir.
Shall we start now?
Yes, sir. Good evening, all. I welcome everyone for Day-3 session. Now, I'd like to give a brief introduction of our esteemed speaker of today's session, Dr. Lalit Singh. Sir received his PhD degree from Indian Institute of Technology, Banaras Hindu University. He is currently a scientist and head of artificial intelligence applications in NPCIL BARC, Department of Atomic Energy, Government of India, and has distinction of working on pressurized heavy water reactors, PHWR, and light water reactors. He is also working as adjunct professor in IIT Gandhinagar, visiting professor in IIIT Galore and BHU, and professor of practice in BJTI Mumbai. He has published several research papers in journals of high impact factor like IEEE transactions, IEEE computer, ACM, etc. He is a senior member of IEEE and member on the advisory board of IEEE Industry Relationships and Entrepreneurship Committee. He has been invited for chief guest, keynote speeches, session chair, and talks in many international conferences, short term courses, workshops, and faculty development programs from many IITs, NITs, and other institutes of national importance. He is recipient of many awards like prestigious IEEE, K. Shankar Award, Publication Award, Group Achievement Award, etc. He is a reviewer of several SCI index journals of high impact factor. And Sir is a lifetime member of Indian Nuclear Society. He is founder member and industrial coordinator of the proposed Center of Dependability at IIT Bhubaneswar. He is in the panel of Faculty Assessment Committee for Department of CSE, IIT Roorkee to assess their research profile and give recommendations. He is a member of editorial board of many reputed journals and guest lead editor of many special issues. He is supervising many PhD students of different IITs, NITs, and his PhD thesis examiner of IITs, NITs, and other reputed institutes. He is an expert member of Industrial Policy Formation of IIT Ropa and Board of Studies of many autonomous institutes and member of on the advisory board of many institutes and universities. He is the reviewer and project collaborator of research proposal of Board of Research in Nuclear Sciences. He is also faculty of Nuclear Training Center, Department of Atomic Energy, Government of India, and he is interfacing with different other countries like Russia, United States of America, France, etc. for importing nuclear reactors that are based on new technologies. His research interests are in the area of reliability, safety, and security of safety critical computer-based systems. So far, he has completed 33 projects of Department of Atomic Energy, Government of India. He holds 520th rank in India in the list of world's scientists released by AD Scientific Index. It's a very big pleasure that we have Dr. Lalit sir here. Now it's my privilege to invite our session speaker, Dr. Lalit Singh sir, to deliver his presciential knowledge and guide us with his vision for faculty development and research on topic artificial intelligence applications in safety critical systems. Lalit sir?
Okay. Yeah, so thank you, madam, first of all, for introducing me. I hope I'm audible to all of you.
Yes, sir.
Yeah, okay, thank you. So to start my session, let me share my screen. Just a moment. So is my screen visible to all of you? Madam, is my screen visible?
Is visible, visible, sir. Visible,
Okay,
sir.
and I'm the slides are changing also.
Yes. Changing, sir. Properly it is changing. Sir.
Yeah. Okay. Fine. Fine. Good. Thank you. Okay. So I'll be talking on artificial intelligence application in safety critical systems. So first of all, let us try to understand what do you understand by safety critical system? So the failure of which can lead to catastrophic disasters, or even it can lead to the loss of human lives. Such systems are known as safety critical systems. And there are the various applications, there are the various domains in which such safety critical systems are being used. That includes aerospace, medical domain, space domain, automobiles, nuclear energy, and so on. So these are the very critical applications because the failure of such systems can lead to very, very severe consequences, and even it can lead to loss of human lives. For example, you might have heard some days back the airplane crash at Gandhinagar. So these are, although these systems are very systematically designed and implemented, but still there's a probability of the failure. So we will see like what could be the artificial intelligence applications for such kind of systems. And because artificial intelligence is a interdisciplinary domain, uh, we have to apply on some particular domain or some particular field. So here I have taken the domain of nuclear power plant because that is also a kind of safety critical system. So let us go through today's agenda. So first I will introduce what actually nuclear power plant is. Then what are the major components of nuclear power plant? How it basically, what are the roles and responsibilities and overall functionality of nuclear power plant? Then after this vertical, the second vertical, I will touch upon the concept of AI, although you would be knowing the artificial intelligence up to now because this program is on AI on itself. So you might have some introductory lectures on AI. But still, for the sake of completion, I will touch upon the concept. And then I will try to marry these two verticals to conceive critical use cases, which are, which will be very suitable for ensuring the reliability and safety of this system. Then we can conclude our session with the references. Yeah. So if you see like nuclear power plant or nuclear reactor, uh, it is a device which can sustain the chain reaction, fission reaction basically. So we all know what is fission reaction because when we used to be in class 11th or 12th, that time we had studied what do you mean by fission reaction. So fission is nothing but it is the process of splitting of heavy nuclei into the smaller nuclei. And when it happens, it releases a huge amount of energy that is 220 million electron volt of energy in each in one fission reaction. Plus, it also generates 2 to 3 neutrons in one reaction, sometimes 2 neutrons, sometimes 3 neutrons. And these neutrons will again strike to fissile material, and each neutron will be responsible to generate one fission reaction. So you can see one fission reaction may lead to 3 more fission reactions because it generates 3 neutrons, and each neutron again will be responsible to create one fission reaction. And then in the next iteration, 3 की power square, that is 3 square reactions. Then in next iterations, 3 cube reactions. And in this way, the number of fission reactions keeps on increasing. And as I said, in every fission reaction, an enormous amount of heat is being released. That is 220 million electron volt of heat energy. And this huge amount of energy, basically, we utilize and to convert it into the electrical energy, because we know energy can neither be created nor be destroyed, but it can be transformed from one state to or from one form to another form. So this heat energy is basically uh, um, transformed into the electrical energy. And now it is very important to understand it is to maintain the chain reaction. Now imagine if in this way the fission reaction keeps on increasing, you will get the amount of heat energy will also keep on increasing exponentially. And you cannot sustain such amount of heat energy into any mechanical component because this is enormous, and hence we have to limit the number of fission reactions. So we have to limit, there should be a steady flow of neutrons. So it is the device which can basically control the neutron population, right? And it is basically generated by fission of the heavy nuclei, as I said. So just that was the basic concept, and to understand basically the principle of working of nuclear power plant. So this is the pictorial representation of nuclear power plant. So we can see, we will try to see what all the components, what are the major components of nuclear power plants, and what are the roles and responsibilities of those components, and how those components are interacting with each other to generate the electricity. So if you are able to see, let me change the pointer size to laser. I think then it will be visible to all, right? So if you are able to see this rectangular box having the round corners, here only the fission reaction takes place. So a lot of heat energy gets accumulated here, and that needs to be transferred. So how it gets transferred? It has one inlet and it has one outlet. And from the inlet, there is a pipe that is going through and coming coming out outward from this side. So inside this pipe is not terminated. Basically, pipe is passing through inside this reactor core. Okay. So here, so when cold water passes in such a hot environment, the heat energy, basically the heat gets transferred into this water, because we know the heat transfer takes place from high temperature to low temperature. Okay. And the water that is coming out in the outlet it contains almost 300 degrees centigrade of water. The water temperature is almost 300 degrees centigrade. So it comes out, and this shell, this bigger vessel having the dome-shaped structure, this is known as steam generator, which logically contain two compartments. And as uh, you say, like, it is a steam generator, so it means it creates the steam, it generates the steam. And how it does. So the water that is coming out having the temperature of 300 degrees centigrade, uh, it passes through the normal water, which is in the lower compartment of this steam generator. So we keep the normal water, and when this hot water touches this normal water, like boiling point of water is 100 degrees centigrade, and after that it starts converting into the steam. So it suddenly gets converted into the steam, and because steam has a lighter density, it gets accumulated on the top portion of the steam generator. And steam has a very high enthalpy, very high energy. So it passes through this, and this is a steam turbine. So basically, it rotates the shaft of the steam turbine because it contains so much of energy. And now what happens? It is coupled with the electric generator, so it generates the electricity, and that will be connected to the grid, northern grid, southern grid, and depending on the country's grid arrangement. Now, the story doesn't end here. Uh, that is now what basically happens. So when this in this circuit, when it exchange the heat to the and the steam is generated, so this water becomes cooled down because it has lost heat for the steam. And this cold water, although having good temperature around 80 degree or 100 degree, but it contains a lot of energy, so I don't want to flush it off. So the same water can again be pumped in, and again it can carry the heat, and again it can be used for generation of steam. In the similar fashion, like the steam, so this is one loop, okay, which keep on running up throughout the operational period of the nuclear reactor, which is generally 40 to 60 years. And the steam here basically steam has are of two types. One is the saturated steam and one is non-saturated steam. So saturated steam is known as dry steam. Why? Because the water content in that steam is very less. So it contains very high energy, and that energy is basically utilized to drive the shaft of the steam, a steam turbine. Okay. And then the non-saturated steam, which contains more water contents or droplets, that basically is being condensed. So we know, like, the condensation process, when any hot thing touches the cold surface, it liquefies, it condenses. So what happens? This is the steam, non-saturated steam, and we convert it touches this area, and in which the cold water is flowing. So from where the cold water is coming, it is that we will see later, but it touches the cold water and it gets converted back into the water, and that can be pumped back again into the steam generator. So this is the secondary loop. And now from where the cold water is coming up. So it can come from the water reservoirs. So if your nuclear power plant is deployed in the coast at the coastal sites where natural water bodies are available, for example, river, lakes, or ocean, it can take the water from those water bodies, and after exchanging the heat, after condensation, the warm water can be pumped back to the sea. Or if the new power plant is deployed on the non-coastal sites, then uh, we have to create the artificial water source of water from which the water can be pumped in. So this is the entire working principle of the nuclear reactor. And if you see like the radioactive, so when I said like the fission, it releases the after splitting because it splits into the smaller nuclei. So generally it releases the two smaller nuclei element, and these are very highly radioactive element, right? How radioactive elements are those whose outer orbits remains empty, and they are in the quench, like they want to quench their outer orbit. So they can they try to react with any body, and that is very cancerous, and hence radioactive elements or radioactive elements are very uh, dangerous for the public. So we should always ensure that such radioactive elements should not be exposed to the normal public. Now coming to one thing, how the neutron population is being controlled. As I said, it has to maintain the chain reaction. It has to sustain the chain reaction. So if you are able to see in this area, the red stripes, rectangular rods, these are the rods, which is generally made up of cadmium or boron, which are basically strong neutron eaters or neutron absorbers. So if I want to control the neutron population in this area, I can drop down the control rod in that area of that area. So it can cover up the maximum area and it can eat up the neutrons. So you can see like all the control rods are hanged by the metallic string. This is the metallic string, and which is basically held by the mechanical clutch. And there is a program. Uh, it can release the respective clutches of the respective rods depending on in which zone I want to decrease or increase the neutron population. So when I want to increase the neutron population, I pull back the rod so that there should not be anything which can eat up the neutron. And if I want to uh, decrease the neutron population, I have to insert the new control rod, and the level of immersion of the control rod can vary depending on how much neutron population I need to control, because I have to maintain the steady flow of the neutrons. Okay, so this is the entire working principle. And moreover, because it is a radioactive element, and it is directly because a lot of radioactive elements are being generated here, because here only the fission reaction takes place. and it is directly coupled with the steam generator, and hence these two components are embedded in a confinement shell or a concrete structure so that and it is maintained in the atmosphere or the atmospheric pressure inside the confinement shell is maintained at negative pressure. Why negative pressure? Because in case there is a leak from this confinement shell, uh, anything from outside can come in, but nothing can go out because we know like uh, the things move from high pressure to low pressure. Okay. Now, so that was the total. That was the one vertical where I just wanted to touch upon the working principle of nuclear power plant. Now, the second vertical that I wanted to touch upon is artificial intelligence. Good. Okay. Artificial intelligence or machine learning. Now, there is a uh, myth, uh, like many of the people generally they think like artificial intelligence and machine learning, they both are same terminology. No, but that is not. There is a very, very thick line between these two. And let's try to understand first the concept of the machine learning. Okay. So machine learning is I just I'd be wanting to explain the concept of machine learning with an example. So suppose there is a newborn baby, and you know the newborn baby, they are very curious to know about the world, to know about the new things. Once they see some new thing, they are very curious to touch. They are very curious to go there and so on. So for example, let us say a mother is holding the baby and taking hot uh, tea also. So as I said, the babies are more curious. They will always try to touch the cup. Generally, it happens, and they get burnt also. So, but next time when they see like, okay, the mom was taking the tea in the similar fashion, they don't touch basically because their mind has already been trained that was the posture that my mom was sitting, and that was the color of the cup, and that was the style she was taking sip. And in this way, he trained his mind like because that time I got hurt, so I should not now touch that basically cups because again I can hurt. Now, so this is known as machine learning because we are learning from the observations. We are giving, for example, in the case of the input was he was touching the hand. This action was an input. Okay. The output was burnt. He got burnt. And the inside the model is what his mind was trained by input and output. So here in machine learning, basically two inputs are given. I just wanted to explain the difference between the traditional programming and machine learning. In the traditional programming, suppose I want to add two numbers. So what all the inputs that I will give? I will give the two numbers, and I will also program like how it adds, it should add, for example, A plus B, and the output will be the resultant sum of these two numbers. Okay. So here in the traditional programming, the input were two, that is the numbers and the algorithm, because I was already knowing the algorithm. And that algorithm operated on the input data and gave the output. This was the traditional mechanism, a traditional programming concept paradigm. But in the case of machine learning, what were the inputs? Here, the input were the like action when baby touches, and input were also like it got burnt. So these were the two input that will go to the mind, which is a machine. And from there, these two inputs, he now his mind will set a model. So here output is a model, and there input was inputs and model, and here input was input and output. Okay, so I hope you understand. Here, artificial in or machine learning, we will not talk about artificial intelligence till now. So machine learning will basically try to create a map or mapper uh, which can map all the inputs and all the outputs. Okay, so he's trying to create a model. Hmm. Now, machine learning basically, so we could understand one thing. It is a data-driven technology because we are trying to learn from the data. As and when we are getting more and more data, I will be able to learn more and more. So it has a machine learning life cycle, which basically contains 7 main phases. In the first phase, first is the gathering the data. We have to capture the data, and then in the second phase, we have to prepare the data. In the data preparation means, for example, I want to know how many students of class 8th is has scored more than 90%. This is my uh, statement. Okay, this is my problem. So what I will do, I will capture the data from the college data, which contains, for example, the marks of all the classes. Then I will apply one filter that I need only a particular class, for example, class 8th. Then so this is a kind of data preparation. We basically when we capture the data, we capture many kind of data, but depending on the problem statement, we filter that data. So it is known as data preparation. So once I have collected the or filtered out the relevant data, I have to do the data wrangling. Now, what is wrangling? Data wrangling. For example, that data may contain lot of consistencies, lot of outliers. Okay, so those things can be removed, because why to why to train with the duplicate data? Unnecessary. It will increase the computational complexity, and it will increase the time, and the data size will also be more. So training with the same data is not going to get anything. Our model cannot be improved. So these kind of inconsistencies or duplicacies, we basically filtered out from the relevant data. That is the data wrangling. Then we have to analyze the data. We analyze the data. Yes, now it is okay. and we can train my machine learning model with that data. Then we have to train the model in the fifth phase. Then, but obvious, after training the model or after making any software or any system, we have to test that. So we have to test the model. And generally in the testing, suppose you are having 100% of data, then 70% of the data is used to test, and 30%, sorry, 70% data is used to train the model, and 30% data will be used to test the model to see, yes, now it is giving the right output. Okay, and then then we can deploy. And if we found during testing it is not giving the right output, we can again go back to through these cycles. So this is the complete machine learning life cycle. Now, I hope you understood the concept of machine learning. So what is artificial intelligence? So taking the same example, as I said, like next time the baby will not touch because earlier he got burnt. So suppose next time, if the mother is taking the cold water in the same cup, and if he does not touch, thinking that it would be hot, then definitely his prediction is wrong, right? So, for example, more curious baby, he touches, he might have seen some difference, and he touches, and he found, oh, this time I have not burnt. Then he could see, okay, last time when she was taking, some vapors were also coming out. In this way, the vapors were not coming out. So he could see from, after touching, and he could take the feedback. And from the feedback, he is revised his learning. He is tuning his model. Yes, I have already, the training has been given, but I am tuning my model by more and more data so that I'll be able to predict more and more accurately. Okay. So AI is nothing, but it is machine learning plus feedback. So generally that is why machine learning is a subset of AI. So I hope now the concept of artificial intelligence and machine learning is very, very clear. Okay. Yeah. And so how we represent basically, so any machine learning model or any artificial intelligence model, it contains minimal three layers. One is the input layer. This is the input layer. And one is the hidden layer. Here I have shown two hidden layers, but just focus on, I said, it contains minimal three layers. So it could contain only one hidden layer and one output layer. Now suppose, so what happens? It is giving from here the inputs are given. It is outputting the decisions, and from input, because it has already been trained. So this model is basically tuned up, and it is able to give the output. Now suppose you do have a very complex data. Complex doesn't necessary to be very voluminous. It may not be very voluminous data. It may be small set of data, but very, very complex means uh, to extract the relevant information, you have to apply more than one filter. So you have to apply more than one computation. Okay. So, so how we can do that? We have to uh, we have to increase the computation power. So one layer was not sufficient basically to for this. Okay, so we have applied more than one hidden layer. That is this and this. So one hidden layer, the first hidden layer may be filtering out some information and giving some information to the second layer, and the second layer is again processing that input and give try to extract the data which is basically required by the output layer. Okay, so once I have more than one hidden layer, it is known as deep learning because we are trying to deeply analyze my data. I have to apply many filters and I'm trying to analyze this very deeply. Okay. So I hope you understood the difference between the machine learning and the deep learning and this artificial intelligence. Now, next is the convolutional neural network. What is convolutional neural network? So when you see like for a small data, that model was good. But suppose you are having very huge amount of data. For example, images. You want to work on the images and you can see like images are the very voluminous data. For example, if you are taking the black and white image and the size of an image is, for example, 500 by 500 pixel, then you can say like because what is matrix? Sorry, what is image? Image is a matrix and it contains rows and columns, and each element represent the pixel intensity. And if I'm saying it is a black and white image and having 500 into 500, so one image, the data contained by one image will be 500 into 500 and into 2. Why into 2? Because it is a black and white image and one pixel may contain two information, either black or white. Now consider the gray image. So gray image, we know one pixel intensity can be from 0 to 255. It means one pixel can contain 256 information. So you can see like the size of one image will be 500 into 500 into 256. How many times? You can imagine more than 120 times, 125 times. Then black and white, and that is only for one image. Now, if I say colored image, so we know like colored image can be up to 1024 pixel intensities. So now the image size will be 500 into 500 into 1024. And now the high definition images are also, people are working. So it may contain 2056 pixels, one pixel, so much of information. So such a huge data, and that is only for one image. And if you want to process thousands of images, lakhs of images, for example, if you would be knowing the DG Yatra application. DG Yatra, when you, because nowadays in the airport there is a lot of rush and the people are using DG Yatra so that they can bypass the security check and automatically they can enter into the airport premises. And DG Yatra is also from the main gate security check and inside also. So you only have to scan and it just scan your face and pass you. So this is how fast it is doing. It is because of that convolutional neural network. So let us try to understand how basically it can process such a fast, uh, it can process such a voluminous data, such lakhs of images in such a fast time. So its framework contains many layers. So this is the input layer in which the images are basically scanned. And this second layer is known as convolutional layer, and it also contains the ReLU layer. Now, what is convolutional layer? Let us try to understand. See, when you just imagine if I want to process each and every data of this matrix or of this image, how much processing power will be required? So I cannot work in that way. I don't have such high processing, uh, you know, high speed processors. So what I do, basically I try to extract some of the important features. We work based on the features, important features. So convolutional layer basically it extracts the important features which are the representative of this image. So it creates a feature map because it maps every set of features with the set of that particular image. So it is also known as activation map. So I don't need to process each and every data, only I have to just see the features, which is a very, less in volume. Then the ReLU layer, what it does, so to make you understand, generally, if you see any image is non-linear in nature. Non-linear means you will find change in the frequencies in between even. You can check yourself wearing any shirt or something. You will find there is a lot of change. Even in the walls, somewhere edge comes, somewhere shadows coming, and so on. So the layer basically, so it contains non-linearity. So when we do the convolution operation to extract the feature map, the it basically the output is linear, and I want to introduce the non-linearity. So ReLU layer basically introduces the non-linearity. How it does, it basically removes all the negative values from the activation map by setting the 0. And then the pooling layer is, so once I have collected all the representative data or the feature data, it may be possible that I can further filter out irrelevant data depending on the context of my problem. If there is a possibility, then pooling layer basically reduce the dimensions of that data further. And these operations can be repeated, may be repeated depending on the size and nature of the data. So it may have more than one replications, convolution plus ReLU, pooling, and so on. Then there is a softmax layer, which basically assigns the probability that this particular image or this particular feature belong to that image. So this basically finally gives the input. So this is the convolutional neural network framework working on the images. So this is the second vertical that I have covered. So first we have seen the nuclear power plant because I want to use artificial intelligence use cases on particular domain, and domain I have selected as nuclear power plants. And second is the artificial intelligence, because we will be using, or we will be designing the use cases for that. So the first use case that I have considered is known as the digital twin. Okay. So I hope uh, the digital twin uh, yeah, I hope the digital twin you may be all aware of the digital twin. And nowadays, many countries, they are trying to create a digital twin. For example, the Singapore is trying to create a digital twin of the entire country. So let us first understand what actually the digital twin is. So as I said, like twin, you must be aware of twin means it is just like identical to one object, like twins. So it is identical to one object. So if I am trying to create a twin of the nuclear power plant, it will be identical to that one. And digital means, so it will not be the real object, but it is a digital version of that particular uh, object. For example, eSIM, right? So it is physically you don't need the SIM, but there is a eSIM. You can configure it in your mobile, and that that will behave like the actual SIM. So let us see what is the development methodology of the digital twin and what are the benefits that we are going to have by creating the digital twin. So first, let us try to understand the methodology of the development. So suppose this is a real nuclear power plant object, and if I want to create a digital twin of this nuclear power plant, I do I should collect the data. And as I told you, because it is a data-driven technology, so definitely I have to collect the data which is required to be replicated, or which I want to create a digital twin. Because I cannot, maybe some objects are very confidential in nature, or some are not required. For example, washroom. Why I need to replicate or create a digital twin of the washroom, right? And similarly, some critical area would be there, which is not allowed to be replicated. So we have to first identify the physical assets. Yes, these are the physical assets of which I need to create a digital twin. So that is the first step. And so, as I said, it needs to behave like the actual nuclear power plant. So we have to understand what is a physical phenomena. These are the inputs basically that we need to prepare. We need to understand how one object is interacting with each other. For example, I had shown like steam generator, the pump, the core, and so on. So we need to understand the interaction protocol among the different objects. Then we also need to understand how many sensors are there. Sensors could be pressure sensors, temperature sensors, venturimeter for to measure the flow, and so on. So I have to understand all the sensors because I have to create a duplicate of that, and how those sensors are interconnected. Probably some are IoT sensors or some are triplicated sensors. And because These sensors help to measure the physical process, like what is the temperature of particular thing, what is the flow, what is the pressure, what is the level, and so on. So all those sensory information we need to have because I want to develop, I want to create the replica of that. Then what are the computing and networking systems? Like you might have seen the Mission Mangal movie, so in which there is a control room. So all those systems are computing systems in which the operator can sit and operator can basically use or control the entire reactor or entire utility. So we need to understand how many servers are there, what are the computer-based systems, and what are the functions of those computer-based systems because the entire thing needs to be replicated. Then procedures and human actions also we need to understand because again I'm referring to the Mission Mangal movie. You might have seen at the first place the mission was failed. The reason was because the operator has told the Vidya Balan was a scientist and she told wrongly to the project manager, yes, all the parameters are correct or are inside the range, but that was not actually, and hence there was an error of the human. So we also have to understand all the human actions because that also needs to be replicated because if any system is being operated by human is considered to be the part of that system. So these are the inputs that basically that we require. Okay. And okay. And now how I will create the digital twin. So there are the two important activities. First of all, whatever the data that I have collected here, I need to plan a database management system. What all the data, how those data will be segregated, and what access right should be given to that data, whether or how many files should be can be created, whether that file can be interconnected to another file, what are the access roles, who can basically access, what should be the password label, and so on. So all these data management needs to be done and needs to be carried out. So we have to define all the storage and sharing and accessibility, but all the data can be visualized by the operator because it may not necessary that all the data will be visualized to the user or required to be to show to the operator. Okay, so these all needs to be uh, uh, created, and then the second one is now we have to create the model and we have to create the simulation. So first we have to analyze all the data. So data analytics, lot of uh, algorithms and all to analyze the data, to understand the data. As you have said, it is one of the critical phase of the machine learning. Okay, so we have to do a lot of data analysis. Then we have to make the machine learning and AI based models, which can give the predictions by from the user experience. And we also have to develop the physics-based models. Physics-based models are first principle models. For example, if I say pressure is equal to rho g h, So rho is the density, G is the gravitational force, and H is the height. And this is a physics formula. So it is a physics-based models. And those models will be used to train the machine learning or AI-based models, because these physics-based models will be able to generate the data based on the first principle, and it can give to the machine learning models to get trained, and later on when it confront the real data, these artificial intelligence based model can be tuned further to give more and more accurate prediction than the physics-based model even. Okay? Because the physics-based models are um, may contain lot of uncertainties depending on the environmental conditions, and which can be accommodated by the machine learning models. And data informed models, if you want to have data models and all, we can develop and other models also as required. So this we have to do. And now the main important thing is this nuclear power plant the actual one has to be directly connected with the digital twin. Why? Because as I said, this artificial intelligence based model keeps on improving, keeps on getting improved based on the real observation. So whenever the new observation comes in, it tunes the AI based model. So what all the thing that it can, that it will flow from the real nuclear power plant to the digital twin. One is asset information. Now it is very important to understand asset information. For example, there were only 100 of process systems, and now 5 more process systems have been conceived. So for that, different computers and all, so many other additional components needs to be incorporated. Mechanical component, electrical component, computer software components, and so on. And these are the assets. These are the physical assets. So it can be scaled up, it can be scaled down. So all these asset information needs to be flown so that the same thing, the exact thing can be updated here itself, here also, okay? Then all the real-time and sensor data so that it can improve the machine learning and artificial intelligence-based model. Then plant and operational maintenance data, so that what should be the maintenance activities and all. It should understand what is the period of maintaining particular thing, particular component, whatever. So these all the information it basically captures from the real environment, and in return it basically gives so many actions and recommendations that includes diagnostics and prognostics. Now it is very important. Let us try to understand what is the difference between diagnostics and prognostics. So suppose there are lakhs of sensors, the field sensors, and if any sensor gets failed, and maybe, the operator have not seen, or maybe because we cannot uh, give the uh, information on health of the sensors, each sensor, we cannot give the information. We cannot show the information, because otherwise, in this way, we may have to deploy lakhs of systems, and which is basically not possible for any operator to give any judgment. So only critical things needs to be shown. So, so suppose any sensor has malfunctioned in between. So it may not be from the traditional mechanism. It may happen. It may not get revealed. But if we use the machine learning or AI based models, it can easily identify the patterns of the data, the pattern in the change, right? So it can easily do the diagnostic information. For example, let us say one uh, uh, real example. Suppose your credit card limit is up to 5 lakhs. Okay. And generally you make a transactions once in a two transactions in a day, for example. And on an average, one transaction is around 10,000, let us say. Now, suppose your credit card is lost and somebody is using. Just assume. And you have now other person has done the shopping of suppose 2 lakhs in a day. Then, although it is within the credit limit, but still there is a deviation in the data pattern, and that deviation is basically understood by the bank, and it makes you a call and to confirm, see, this is the big transaction and whether you have really done it. And then when you confirm, then it basically logs in. So like in such a way, diagnostics means although the sensor may be giving or any component may be working in the range of already predefined limits, but there is a significant change in that pattern which cannot, so traditional mechanism cannot analyze because it will just see whether it is inside the range. But machine learning algorithm minutely understands the pattern, and it basically can understands in the faster manner about the diagnostic information that which component has been malfunctioned or failed. And prognostics. Now, what is prognostics? So prognostics basically is a prediction when anything is going to fail. So suppose it can tell like, okay, it will fail after uh, 12 weeks. It can fail after 14 weeks by understanding the pattern or the trend. So it is so powerful tool. Then it can give the operational and maintenance recommendations that operator should do this, operator should uh, turn on this uh, hardwire switch or whatever actions like or soft controls if you do have we must close this wall, open that wall, and so on. Many recommendations depending on the process related to the process can be given by the digital twin, which is not possible using the traditional mechanism. And autonomous operation and controls. All the controls, like, recommendations can be given and actions can also be taken up. So this is this can be used for the more reliable and safe operation of the nuclear power plant. And a real use case has been developed. A digital twin was developed by a metroscope in France. So basically, Metroscope is a sister concern of EDF France, which is responsible for all the nuclear business in the France. So what basically this digital twin, how it is helpful, it proved to be helpful. Actually, a digital twin was estimating that this nuclear power plant should produce 963.5 megawatt of energy. Uh, but it was producing 959.9. So there was almost like 3 to 4 megawatt loss were there. Uh, and this was a huge loss, basically, per hour. And this twin identified this loss is basically because of many tube ruptures, small tube ruptures inside the, feed water heater. And because of this, it got revealed and it got rectified and could save a lot of economy as well as safety. Now, more real use case is Cortex, which was a European project. And there was 20 partners across 11 countries from Europe. The total budget of this project was 55 lakhs euro. And it started in 2017 and, it's up to 4 years, 48 months. And this was all about to understand the physical phenomena that is going through inside the reactor core, how many number of neutrons are getting generated, the state of the radioactive elements, and so on. All the fission reaction details, basically, it was able to capture and predict, basically. So that it can ensure, like, yes, my reactor is in the safe operation, and because ultimately the source of the radioactive element is the core only, where the nuclear fission basically is taking place. Then sensor or equipment fault detection, like suppose there's a normal data and it can understand the faulty data by several algorithms. Similarly, the predictive maintenance, it is a real use case, like Rosatom. Rosatom developed this use case, which is responsible for all the nuclear business in Russia. And this turbine or turbo generator is the most expensive component. And if there is any malfunction in the turbine, we have to shut down the reactor on emergency basis. And basically, which is costly, because if the reactor is shutting down, it is almost 1 million euro loss profit per day. It is such a huge loss. And so they have developed the AI-based solution to do the predictive analysis to identify the faults in advance, much advanced, so that the predictive actions can be taken up to rectify that. Then flow accelerated corrosions, because there are a lot of mechanical pipe, lakhs of pipes. So where the corrosion exists and all, they can easily understand the mechanism and they can identify, like, so EPRI, the Europe, they have collected 27,000 inspection data sets from 48 different units of power plants, and using that, they train their AI model, and it gives a very good accurate prediction. Then damage in the concrete structures, like if there is a damage, internal damage, which is not possible to identify using the traditional mechanism, the AI-based models can capture the images and it can analyze the images and it can predict, basically. So then prognostic analysis, IAEA, that is International Atomic Energy Agency, they have developed when the component is going to fail, and it is used to the spare parts management. Because if I know after 1 year or after 6 months this component is going to fail, I can manage my procurement process. Because if I procure anything much early, many of the equipment are very, very costly. And if they are not placed in the operational, their life keeps on deteriorating, and that will be the huge loss. Then human error detection also, to identify the human errors So they are the human reliability models using which the AI models are being trained to identify the human errors. For example, you might have seen in today's car, suppose any driver is drunk or he's feeling drowsy, automatically the alert AI-based system is there. It can show the alert like you are drowsy by understanding that particular day pattern of operator and normal day pattern of that operator's action patterns. Then transient identification, if any transient has occurred and all, so many support systems basically has been developed. Predictive analysis, where the things has been failed. So in conclusion, the AI proves to be very beneficial for ensuring the reliability, the safety for the safety critical systems. We have seen the use several use cases on nuclear power plant domain, and it can be used for design optimization and prediction, because if I'm able to create the digital twin, I can, as a process engineer or process scientist, I can understand how my system is basically behaving, and I may think of like to improve that system. So I can do a lot of optimizations and all. Anomaly detection or equipment pre-health monitoring, plant diagnostics and prognostics, operator interactions can be enhanced. Cyber attack detection also, you may be knowing, like AI-based cyber attack detection is very, very widely used and to be beneficial. Physical protection also, because in the security it can understand like, okay, if any new person has been entered into a control room which have not been seen earlier, it can pose a physical threat. So operation decision support and all. So that's all about this session. So in case you will be more interested about the AI-based algorithms and all on the AI, so you can subscribe this channel also. This is where I basically upload the videos. So the interested one can look also. So thank you very much for your patience listening. And these are the references from which the use cases has been taken up, which are the real use cases. So if anybody want, they can definitely refer all those references deeply to understand what is the development methodology and all. Thank you.
Thank you, sir. Thank you so much. So we are eager to meet you again in tomorrow's session, sir.
Yeah.
Yeah. Thank you, sir.
Okay.
Madam.
Yes, sir.
So we will give you a break for 6 minutes. Again, the next session will resume at 7:30 p.m.
Okay, sir. So dear participants, if anyone didn't submit your attendance come feedback, please submit that link. Okay.
The speaker is ready. We will be take the session at 7:30 p.m.
Uma madam,
Sir.
you can start.
Sir, Aryan Krishna Karthik, sir. Sir.
Hi, sir.
Good evening, sir. Krishna Karthik, sir. Good evening, sir.
Good evening. Good evening, sir.
We have already given the co-host permission to you, sir.
Yeah, I could see it now, sir.
Okay. No, madam.
Yes, sir.
You can take the session.
Yes, sir. So before starting the session, I would like to give a brief introduction of our esteemed speaker of today's session, Mr. Aryan Shivakrishna Karthik. So, sir is currently working as a software and cloud architect, AI and machine learning engineer at Applied Information Services in Hyderabad. He is an innovative architect with 18 plus years across artificial intelligence, machine learning, cloud, and full stack expert in retrieval augmented generation, that is RAG, and generative AI and cloud native enterprise platforms. He is a proven leader mentoring teams, embedding responsible AI governance, and delivering high impact business outcomes. And his key strengths are AI, ML architecture, and RAG systems, cloud and DevOps. Those are mostly covers with AWS, Azure, K8s, and Terraform, including like a cross-functional leadership and mentoring, LLM integration, enterprise architecture and scalability, and hybrid search vector DBs prompting. Like it's a big honor to us and fortune to have you, sir.
Thank you, ma'am.
Yeah, please deliver his session, sir. Thank you, sir.
Yeah, thank you, ma'am. Good evening, everyone. Can you all see the screen that I'm sharing?
Yes, sir. It is visible, sir.
Okay, sir. Hi, everyone. My name is Aryan Shivakrishna Karthik, and today we will be talking about a topic that sits at the intersection of technology and humanity, the ethical implications of AI in cybersecurity. We are going to ground our discussion very relatable and very human example. See, this particular topic, it's not a complete, of course, it is based on technical, but we need to understand it from the human perspective. And also, we should cover with some live example. We'll be taking AI fraud detection in banking. So why banking? Because it touches every single one of us. We rely on it for our daily lives, for bills, shopping, emergencies. So when AI and cybersecurity intersect here, it's not just a technical conversation, it's a conversation about our trust, our livelihoods, and our survival. So the session roadmap. Here's our roadmap for the session. We'll walk through 7 key ethical pillars that form the foundation of this discussion. Bias, privacy, autonomy, explainability, accountability, dual use, and what are the best practices. So throughout we'll keep returning to our central example. So in every subtopic of this, we will be focusing on the core example. So that is AI-based fraud detection in banking. This will help us move beyond abstract theory and focus on real-world human impact. That is how we can easily understand the impacts. For example, what happens when an AI system judges your account as suspicious with no reason and freezes it overnight? The balances, what we're maintaining, the regular expenses, everything comes to stale. So we'll go through such scenarios in this. Yeah, before that, why AI in cybersecurity? So cybersecurity today faces an overwhelming challenge, very big challenge, like explosion of data. There are huge TBs of data. We're talking about billions of transactions, endless network traffic. Mm, every second there are millions of operations that are being performed, and thousands of security alerts every second. So humans alone simply cannot manage this scale and speed. Definitely we need to depend on AI systems for this. This is where AI steps in. AI brings three crucial powers to the table. One is speed, scale, and predictive power. So it can analyze data instantly. A human analyst can review maybe a few hundreds transactions a day. But AI system can analyze millions in real time. For example, for a credit card company, this means checking a fraudulent charge before it even completes. Before even the user enters the OTP, the fraudulent transaction can be detected. So thereby preventing the transaction to happen. When it comes to scale, it monitors millions of events at once. Think about a global bank with billions of transactions daily. So AI can monitor all of them simultaneously, providing comprehensive security that was previously impossible. Predictive power. It spots patterns that humans might miss. For example, an AI might detect a subtle change in your spending habits, like a series of small, unusual transactions that, when combined, signal a higher probability of fraud. This ability to connect disparate data points is a massive advantage. So, but and this is the crucial part. With great power comes great responsibility also. If we hand over high stakes decision making to machines, we must also transfer ethical responsibility to missions. But is it possible? Are missions ready to take the ethical responsibility? We must ask, who ensures that AI is fair and accountable? So that is going to be the major topic here. So the 3 points, explosion of data, and AI brings speed and scale and predictive power. But with great power comes great ethical responsibility. So next, cybersecurity use cases for AI. So we are talking about until now that we understood certainly there is an advantage in using AI in cybersecurity. So let's see some use cases. Intrusion detection. AI spots unusual traffic that could signal an attacker's presence. Fraud detection, especially in finance. Malware analytics. It recognizes malicious software. Insider threat modeling notices if an employee exhibits any unusual behavior that might indicate a data breach. Cyber threat intelligence. It scans vast amounts of data, including from the dark web, to predict and prepare for attacks. Each of these immense benefits, uh, but also raises serious ethical concerns. Think about insider monitoring. It is predicting the company or invading the employee privacy. These are the tensions we will explore. So the ethical question. If AI decides who is suspicious, are we comfortable letting it decide without human input? See, right now, how it is happening with practical examples, say, consider our judiciary system. So, the court, the team of judges decides if a particular, in any particular case, whether the culprit is punishable or not, if we had done any crime or not. So it's based on human intelligence with a lot of study, humanities, and practice. But here, can AI do this? That is the ethical question. This will be the core of our discussion. If an AI decides who is suspicious, are we comfortable letting in without human input? On one side, we have security, the need to protect our systems and money. On the other side, we have fairness, the need to ensure that individuals are not wrongly accused or harmed. If AI is designed to prioritize security above all else, it might take decisions that are highly effective at preventing fraud, but at high cost. But what cost? It might be at the cost of innocent people. The goal of ethical AI is to find the right balance, ensuring we don't sacrifice for one another. So we will see one use case: banking for fraud detection. Here, the scenario, say for example, one fine morning we woke up and we see a message like suspicious activity detected, investigation going on. So, say if our bank account is freezed, then we'll be in panic. We can't do any bills, remittances. The regular business gets disturbed. So, say for what are on that day, if there are 10 transactions that are, for example, we are doing a small business and we need to pay our employees. Our employees can't be paid. Supply chain is stalled. So the entire financial life is on hold. All because an algorithm made a judgment call. This isn't a hypothetical scenario because banks around the world are already using AI systems that can make these calls automatically. So why this example matters? Banking touches everyone's life. Fraud detection is also is a classic cybersecurity AI use case, and it directly impacts the human. So a blocked account isn't just an inconvenience. It can mean missed, say, rentals or stalled business, inability to pay for see if there is some financial emergency. So we can't pay the bills, right? So this is where ethical principles become not just academic concepts, but a matter of trust and human well-being. So let's see the first ethical tension. This brings us to our first ethical tension. AI detects anomalies, but anomalies are not always fraud. Like, if there is a pattern of payments being done, say, there is a user and every day he's doing some 10 transactions of almost equal amount. But if there is a situation where he's doing some large transaction during the same window, uh, it's actually a rightful transaction, but there is a chance that it can be detected by AI as an anomaly. So, for example, an AI system is trying to flag unusual international spending. What if a loyal customer who spends shops locally suddenly made a large, excuse me, suddenly he makes a large purchase from a foreign website while on a vacation? Okay, the AI may flag it as suspicious. That is false positive. So here innocent people are caught in the net, and false positives aren't just irritating or annoying. they can have real financial, emotional, or even reputational consequences. What if in this example, the particular person who was dependent on his debit or credit card was in foreign land, and his financial, if it is detected as false positive, his financial would be affected on a foreign land. It is very alarming situation. So we must ask how many false positives are acceptable in the during the training. So who gets to decide what the acceptable level of harm is for a small number of people to protect a larger system? So uh, here there is a ethical framework. We need to distinguish between a fraud and a legitimate user. So here the ethical frameworks is it's like fairness. Does the system treat all customers equally? And accountability. Who is responsible when AI makes wrong decision? Transparency. Can we understand how the AI came to a decision? Explainability. Can the system explain its reasoning to a human? So by acronym, this is called FATE, F-A-T-E. So fairness, accountability, transparency, and explainability. These aren't just academic concepts, they're particular guardrails for AI in critical areas like banking and national security. Throughput, the rest of the session, we'll apply these to our banking case study. Fairness, accountability, transparency, and explainability. So to close this introduction, if AI system disappropriately flags certain groups, say people from specific regions or with specific spending habits, is that ethical? This leads us directly to our next major theme, bias and fairness. Because before we can talk about AI making decisions, we need to examine whether those decisions are fair or not in the first place. So bias and fairness in AI cybersecurity. Who does the AI really protect? This is going to be the next subtopic. So let's understand what is bias in AI. Give me a sec. Yeah. So what is bias in AI? So this section asks a critical question that gets into heart of the matter. Who does the AI really protect? Is it protecting the bank in our use case, or is it also protecting the customer? This framing will guide our entire discussion. Sometimes it can be like it is protecting the customer by preventing a cyber threat and saving his bank account finances. But most of the time, it might be a different case. So what is bias? At its core, bias in AI means systematic unfairness. Systematic unfairness in how an AI makes predictions or decisions. It's not a bug actually. Biasing is not a bug. It's a feature of how the system was built on, how it was trained on, how it was built. In cybersecurity, this can manifest as unequal treatment of certain users, regions, or behaviors. This isn't just a technical glitch, it can create real world discrimination. For example, if most fraud investigations in the past historically target in certain countries, for example, some countries like some African countries, An AI trained on that old skewed data might unfairly flag transactions from those regions, even if they are completely legitimate. This is how human bias from the past can be automated and scaled in the future by AI. It generally happens with human also. If we see some, people from Africa, some 2 3 years back, there used to be so many WhatsApp kind of messages, WhatsApp or Telegram messages from African countries. So by sending some links, if we click on that links, there might be some malware installed or some financial fraud might happen. So most of these are bound to Western African countries in the earlier days. So if we meet people from that country, we might also have some world history, world memory. Like, so in the same way, AI might also, based on how it was trained on. So out of 1 lakh fraudulent transactions, if there are 50 lakh, no, 50,000 transactions from a particular region, even AI might be biased. Okay. So this is how human bias from the past can be automated and scaled into the future. So we have audited and we have mm, reported those things to some systems on which AI was trained. So sources of bias, training data skewed, feature selection, and labeling errors. So bias often creeps into AI systems through these 3 key sources. Training data skew. This is the most common source. If the AI learns from a data set where most flagged fraud cases come from specific geographics or demographics, AI will learn to associate those groups with risk. If it's not a flaw in the algorithm's logic, it's a reflection of the flawed data. So it might sometimes be a flawed data that was given. So it's a training data skew issue. The second one is features collection. So this is about what an engineer choose to focus on. They might select indicators like unusual transaction time, like in the midnight, to predict a fraud, but this can unfairly affect people who work in night shifts or international travels who spend money at odd hours due to time zone differences. The future itself, while seemingly neutral, can create unfairness. Sometimes for some of the people it might be okay because suppose if this algorithm is specific to India, an Indian bank, and any transaction in the midnight, uh, any at out of some specific limit, if it is being targeted as a fraudulent, it might affect certain groups of people in the same country, even though we are in the same time zone. So sometimes it might, be problematic in emergency situation. So this is one of the source of bias. Next is labeling errors. This is where past human bias is backed in. If past investigators perhaps are due to subconscious bias, flagged innocent people as fraudulent, the AI learns the same bias. The AI thinks these are examples of fraud, when in reality they are examples of human injustice. So these are the important source of bias. Let's see an example, banking fraud detection case. So let's return to our banking example and make it some personal. Consider a migrant workers who spend money, who send money to home to their families. These remittances are in a lifeline. But from an AS perspective, a high volume of transactions going to a certain countries might look suspicious. For example, so many people work in Kuwait, UAE, they send their salary to the families in India. So Because of the historical training data may have included a disappropriate number of frauds cases from those regions, even if the vast majority of the transactions were legitimate, the result is that innocent workers are fairly punished. Their funds are delayed, their accounts are frozen, and they are treated as criminals without cause. So this is where ethics becomes deeply personal. Bias doesn't just exist in theory; it impacts livelihoods and creates deep mistrust. So this is the example of some practical real world example we might have seen, you know, or some of my us might have practically experienced when doing some international transfers. So understanding false positives versus false negatives. The conversation about bias is really a conversation about error management. Two major error types drive fairness concerns, um, false positive and false negative. This is when an innocent user is flagged as a fraudster, their account is frozen, their transaction is blocked. This causes immense financial and emotional stress. From a technical standpoint, the system is working, it's flagging something unusual. But from a human perspective, it's a failure of fairness. That is false positive. That is, that transaction is legitimate, but it was flagged as a fraud transaction. And coming to false negative, this is when a real fraudster slips through a system undetected. The AI fails to spot the criminal activity, and the bank and customers suffer financial losses. So here, these are two issues. Like in the justice also, in the law, they say, an innocent should not suffer. But here, when it comes to AI, by using AI systems, both the cases might happen as in the real world. So both outcomes are bad, but they impact different groups. A system with a higher rate of false positives might be very effective at catching fraud, but it comes to the at the cost of unfairly burdening innocent people. We must constantly balance the need to protect the system without unjustly punishing people. So this is a continuation of the previous example. Say there is a customer in Kerala sending 10,000 to family. Suppose he's working in say UAE and he's sending 10,000 to family abroad, and the transaction gets failed. Just understand. Uh, okay, but the A system trained on historical data flags it as a possible money laundering. So you all might have known, be aware of the term money laundering, right? So it's a practice known as structuring where criminals break up large amount into smaller amounts and transfer from different accounts. So the funds are delayed. The family suffers due to delayed support, and trust in the system erodes. The customer feels a sense of helplessness, knowing they are being judged by a mission they cannot reason with. In another example, we all, most of us order from Zomato or Swiggy. So many times it happens like we might have um, the taste of the food is not bad, or we might receive wrong food, or some other delay in the delivery. We might approach the Zomato support. Now, who is taking the Zomato support? It's not 5 years back. No human is speaking to us. The AI is speaking to us. It will not understand our emotion because food is connected with emotion. But what it says, how the algorithm is written and how it is trained, that's how it responds. It will not understand. Even I have faced this kind of situation practically with Zomato. It might happen with any kind of AI automated system. So now let's visualize the bias. See, there's some algorithm case like 90% of excuse me. Yeah, I'm back. So in this case, so that this data visualization can help expose the problem. Imagine a simpler bar chart. Say one bar shows the number of flagged fraud cases, and another bar shows the percentage of those cases that involve migrant remittances, say under 20,000. It's likely that a huge percentage of the flagged cases fall into this category. So, yet as a security expert, you know that in reality, the vast majority of these are genuine transactions. So the bias exaggerates suspicion against vulnerable groups. This shows how numbers, while seemingly objective, can reveal systematic unfairness. So the ethical question here: is it ethical to protect the bank by wrongly targeting vulnerable groups? So who bears the cost of bias? So we must pause and ask: is it truly ethical to protect the bank? So if you are able to catch the example, you know, and just to see if it's happening for our families. Say if there is our brother or any of our cousin who's transferring some 2 lakh rupees to us from abroad, and that, but we are dealing some important financial transactions back in India here, and if that amount was stuck up with bank and we could meet our timeline. So who to blame, the bank or the algorithms? So what to do for that? What are the policies we'll understand in the next going further? We'll also see one more example, you know. So bias in facial recognition. So AI access control wrongly denies access and to, it blocks the employees. So bias is not in financial issues, as I have mentioned another example also. So considering financial facial recognition, excuse me, consider facial recognition to access controls in a workplace. So numerous studies have shown that AI systems often have higher error rates in identifying people with darker skin tones, particularly women. So this can lead to the system wrongly denying access to black employees more often than their white counterparts. This reinforces the idea that bias is not about numbers alone. So it touches identity, touches ethnics, it touches groups, dignity, and creates a two-tier system of trust and access. So it's one of the human emotion example. So frameworks for fairness. So how do we address bias in systematic way? Thankfully, ethical frameworks give us direction. NIST AI risk management framework. This framework makes fairness a core principle for any AI system. It moves fairness from a nice to have to a foundational requirement. And EU AI Act. This landmark regulation classifies financial AI systems like fraud detection as high risk. This designation isn't an accusation, it's a regulatory signal that these systems require mandatory bias audits and safeguards before they can be deployed. These frameworks signal the fairness. It's not optional. Regulatory. It's a regulatory and an ethical requirement for an AI system. So fixing bias in AI systems. So to truly fix the bias, organizations must act on multiple fronts. Use diverse data sets. We must feed the AI with representative data so that it doesn't learn only from skewed history. Conduct regular fairness audits. These are independent checks on system outputs. They ask, is the system being fair to all groups all the time? So some kind of audits. Provide human override. Innocent customers should be able to get the situation cleared quickly. A human analyst should always have the final say, final decision making on high stake decisions. And ensuring transparency. Customers should know why they're flagged, and they should have a clear path to appeal a decision. For example, you was say if AI is dealing with credit score, CIBIL score, and we have applied for a personal loan and it was denied. So there should be transparency. A customer should understand why his loan is rejected, and there should be platform to raise questions, to appeal to higher authorities. So this is all about some of the practices to fix bias in AI systems. So we'll go to the next topic. So to reduce frauds, banks collects every detail of our transactions. No, but how far is too far? Like mm, every transaction is being collected. Like suppose humans might not be interested to share if they're having if they're consuming alcohol at some restaurant, they might not share it in the family itself, but banks know everything. No, so this is about privacy. So transition to privacy and surveillance is going to be our next topic. So the privacy and the surveillance in AI cybersecurity. Uh, okay, we'll one second. Let me pull one more slide. Okay. Why privacy matters in cybersecurity? Cybersecurity, by its very nature, requires monitoring. It detects threats. We have to watch user activities, transactions, and network behaviors. But the advent of human, but with the advent of AI, the advent of AI fundamentally changes the scaling of this monitoring. A human analyst can only review, say, hundreds of logs, but an AI system can monitor millions of records in real time from every single user. This creates an environment of pervasive, constant surveillance. The central tension in is this. While monitoring is absolutely necessary for security, where is the line where it becomes a violation of personal privacy? So it's like, where is the line where it becomes the violation of personal privacy? So what's the balance? What's the line? So too much surveillance threats privacy, trust, and compliance. But for cybersecurity, it's important that we monitor logs, behavior, network, transactions. So we'll again see the banking fraud detection example. Let's use our banking example to make this concrete and relatable. A bank deploys an AI system that scans every single transaction. It's not just looking for a fraudulent charge. It's looking at who you pay, where you shop, and at what time of the day. It knows if you bought groceries or a new video game. It knows if you paid your rent or donated to a charity. The key teaching point here is that protecting against fraud comes at the cost of extensive granular data collection that tracks even your most, you know, even every single rupee transaction. So it monitors everyday purchases. So it will understand who you pay, where and when. So bank AI systems scan every transaction detail. So here is the ethical tension. So is it crossing the line of surveillance? This is very, this is where the line begins to blur. AI doesn't just detect known fraud, it goes a step further by building a comprehensive profile of our entire behavior. Here, in this case, for the financial behavior. A late night payment might be marked as suspicious. A series of multiple small transfers could be flagged as a money laundering tactic. Uh, that means our in ordinary life, the way we live, we work, spend, is being continuously monitored and analyzed. At this point, does this essentially uh, do fraud prevention? So at what point actually? At what point does this essentially fraud prevention activity becomes a mass surveillance? So here is the ethical tension is between the security and privacy. How much intrusion is acceptable? Do I need to give up my privacy for safety? So this brings us to the core ethical dilemma of this section. Do I need to give up my privacy for safety? This is a fundamental trade-off. We want our banks to protect our money, but we also want to feel that our financial lives are our own. We must encourage the audience to reflect how much intrusion are we willing to tolerate for the sake of collective security. What if the cost of that security is the feeling that you are constantly being watched by a silent, invisible AI system? So there should be a striking balance. So think about in the earlier example where a migrant worker, had transferred money to India for his home. So beyond if his account is frozen, beyond the pain of the frozen account is also an emotional impact. After his funds are repeatedly flagged, he begins to feel that the bank is not a trusted partner, but an adversary. He feels watched more than he feels protected. This erosion of trust caused by feeling of constant surveillance can have a far greater long-term impact than a single block transaction. As simple as he might switch to other bank, or he might, use some unfair practices, or risky practices, or suppose his transactions are being blocked constantly, he might choose to, send transfer money by other source of means with, with maybe with higher interest transfer rates. So yeah, if there is a customer on one side, a flow leading to an AI fraud detection system, and the other side, a profile being created. The key is to emphasize that while the AI's goal is to predict fraud risk, a secondary effect is that it gathers sensitive insights into private habits like our grocery shopping, travel patterns, or even charitable donations. This highlights the dual use of nature of AI monitoring. It's a sword of the defender, but it's also a lens for the survivor. We'll see one more example, employee monitoring. The companies deploy AI to track keystrokes, emails. The surveillance is justified as insider threat detection, but employee feels loss of trust. The morality dips. Now, to show that these risks are extended beyond banking, this example is a great use case. Let's look at this employee monitoring. You know, when the companies deploy AI systems that monitor everything from keystrokes or screen activity or email and the network traffic, what he's browsing, everything. This is justified under the banner of insider threat detection. However, this creates a climate of constant surveillance. The ethical concern is that employee feels a profound loss of privacy and trust, leading to reduced moral and toxic work environment. The AI's benefit of detecting one bad actor may come at the cost of alienating the entire workspace. So here, companies might need to decide what practices they need to follow. So for this, we have certain policies, regulation and privacy laws. The GDPR, General Data Protection Regulation. This landmark law gives the citizens the right to data minimization, meaning organizations should only collect data that is absolutely necessary. It also gives them the right to an explanation for their data, how their data is used. RBI and FATF, regulations from the Reserve Bank of India and the Financial Action Task Force on Anti-Money Laundering (AML) impose strict monitoring requirements on banks, but also require them to protect customer data. So this makes sure that data is not shared to anyone unless necessary in intrusion cases, that to authorized banking officials only. So the UAI Act. This legislation labels financial AI as high risk, imposing strict privacy and security controls. The point is that regulation is trying to balance innovation with the protection of individual rights, fixing the privacy intrusion with no, we need collecting only necessary data. Adhere to the principle of data minimization here. Don't collect information just because we can collect. Apply anonymization or pseudonymization. So this means making personal information so that AI can still analyze patterns without identifying specific individuals, like masking their identities. Maintain audit trails. Regular audit trails, or every time the AI flags or acts on a user's data, there should be a clear record or audit trail for review. And inform the users transparently. Users should know exactly what AI-driven monitoring is taking place and why. This is crucial for rebuilding the trust. Here, there is one ethical question for the audience here. So, would we allow our bank to monitor every transaction detail if it reduces fraud by 30%? See, we know that every year there is an increase of fraud transactions. The last 2 or 3 days, the union government has declared some figures. It's in thousands of crores, of course. So imagine if it is reducing, there is an entire AI system controlled by RBI, and if the fraud rate is being, controlled by 30%, would we allow some RBI or some third party, some software company to monitor our transactions, every transactions, just like thinking on this angle, and makes we can understand. So these forces to weigh the tangible security benefits against the intangible but very real costs of privacy. So next, We'll transition to next topic. Say, when AI detects suspicious behavior, should it be allowed to act on its own? So this is very interesting topic. See, when an AI detects suspicious behavior, uh, should it be allowed to act on its own without a human to review the decision? This naturally transitions into the topic of autonomy and human in the loop. So it's like giving autonomous decision making to AI. Should AI make final security decisions? Is the key ask here. What in cybersecurity? What autonomy means in cybersecurity? Let's define what we mean by autonomy in this context. It's not just about AI that detects a threat. It's about an AI that also decides and acts on the threat, all without requiring a human to confirm its decision. Here are some examples that illustrate this. An AI blocking the bank account after detecting a series of unusual transactions. An AI-powered system making automatically quarantining a server that if it has signs of being infected by malware. In AI system denying the user access to a network after multiple login attempts seems suspicious. If they are just an employee who forgot their password, so it's we face this problem most often. We might have forgotten a password to some kind of system, and yeah, generally it is in practice before the AI also in the last 10, 15 years. We forgot the ATM pin. After 3 attempts, the ATM card gets blocked. So how it is we are handling in the case of AI? Autonomy is so attractive to security teams because of its speed. See, if there are 100 fraudulent transactions and the human needs to act on that, it might take so much time. And meanwhile, the capacity of the fraud might increase. It's like, if there is a crime happened, police investigate and, they, if they're suspicious on a few, any people, they might ask them to come and report at the nearby station and do some basic inquiry. It's only on suspicion. They might not be real culprits. But at what cost? Sometimes it might, it lead to wrong motives. But most of the time, as per law at least, for the good cause to find the real, to investigate the real crime. So it's like a collateral damage sometimes. So as an AI can react in milliseconds, while a human analyst might take minutes or even hours to review an alert. So here, this is a dangerous case. Imagine if police investigations are also given to AI. Right now, how it is happening, the police, they might question people nearby any crime scene, some neighbors or someone. But what if AI can, can track the mobile usage of all the people, surrounding people nearby a crime area. And suppose it is, making some decisions and sending some legal notices by itself. This is a very alarming situation. So that is why the policies, the governance, AI governance, everything are in place. So let's come back to the banking fraud detection case. So AI detects suspicious transactions, automatically freezes account. So no human review at the time. the customer is stranded. The problem here is that there is no human review at that crucial moment. The result is that a customer who may be innocent person traveling or making a legitimate international purchase is suddenly stranded. Imagine you're traveling abroad and you go to pay for a taxi or a meal, but the card doesn't work. How would you feel? You're not dealing with a person, you're fighting with a mission. Another one, very practical example. So think that we're having a small business and we're a small business owner. The AI system acting anonymously, it has automatic decision power and it's acting autonomously freezing our account. Then we can't pay to suppliers and employees. The supply chain is halted. By the time human analyst finally gets around to reviewing the case, which could be hours or later, the damage is not reversible. Especially if, for example, if the business is dealing with some perishable goods like vegetables or some bakery items, so the products might be damaged. The vendor might not take responsibility. So this is where we see that speed without context can lead to significant harm. When AI acts without oversight, it's not just about a technical mistake, it's about a machine's decision affecting humans' lives and livelihoods. And again comes the ethical question. Should AI have the authority to deny someone access to their own money? So it's a very big and important question. So this in a broader sense, we can say it's like we're not having access to our own digital property. And to push this further, if a mistake happens, if an innocent person's account is frozen, who is responsible for fixing the situation and restoring trust? Is the bank, the AI development team, or regulatory body? This is an no accountability question that flows directly from the power of autonomy. So there is a risk of full autonomy. Full autonomy comes with significant risks that we must be aware of. Overblocking, underblocking, and no appeal. This is a risk of overzealous AI. The ACE model is designed to be highly sensitive to protect the bank, which results in a high rate of false positives. Innocent users get locked out, causing frustration and damage to the bank's reputation. Underblocking. Cyber criminals are constantly evolving their tactics. They are human and they're innovative. An autonomous AI system, which learns from past data, may be too rigid to detect a new, never before seen attack vector. In this case, a human analyst might have spotted the unusual pattern, but the autonomous system fails, allowing a sophisticated attack to succeed. We can see this. We can apply these to ourselves. Many cyber criminals, the pattern of cybercrime have changed. If something is being known to public, they're coming with other patterns. Some small example, like they some WhatsApp messages might be circulated, like if we have land and we give the land for rent to mobile companies to install mobile towers, will be paid monthly some so and so rent. But for that, we need to pay some deposit amount. So even mobile companies have circulated messages that these kind of messages are fraud. Even before this, even before this no cyber crimes related to finance, some even 10 years before, there are some other kind of cyber crimes, like especially from Hotmail or Outlook, that they used to email that there is a lottery won by you, some UK lottery or something, and if you need to receive that, you need to pay this man thousands or lakhs of rupees. And also like parcels, pretending them from a courier office. They calls and they say that you have a parcel, and if you need to get that, you need to pay this much amount. So every time they are changing the patterns, so that might not be detected by AI. And no appeal. One of the most frustrating aspects of a user is the feeling of powerlessness. When AI says no, there is no human to reason with, this can lead to the computer said no. The problem where a user is caught in a loop of automated responses with no clear path of resolution. It happens to us when we're chatting with the AI bot. Earlier, as I told with an example of Zomato. So the problem here is mm, we are asking a problem, we're discussing a problem, but we are getting the responses from the AI agent. Uh, we're talking to it emotionally. We forget that it's an agent. Although we know, we'll say no, no, this is causing problem. Mhm. But it will not understand our emotion. Again, the AI replies. It's like a loop. So autonomy without human oversight, and it's very dangerous and irresponsible. I'll give one healthcare incident example. Let's look in yeah, higher stakes example, like this healthcare incident. Imagine an AI system designed for instant response in a hospital. Its job is to detect ransomware. So at 3 a.m. in the morning, it detects a suspicious file. The network and acts autonomously, quarantines the entire network to prevent the spread. However, in doing so, it takes critical systems offline, systems that are currently supporting a patient mid surgery. In this life versus system dilemma, should the AI prioritize saving files and the hospital's data or saving a human life? This is a moral question that autonomy forces us to confront. So this is a very critical scenario. So the resolution is like role of human in the loop. So how do we get the benefits of AI's speed without risk of its blind autonomy? The answer is a human in the loop model. It's a partnership between human and machine. The AI's role is to handle the speed and scale. It filters through millions of data points and flags potential threats. The human's role is to handle the judgment and ethics. They review the flagged items, add context, and make the final decision. So the final decision will be done by one. This model allows us to leverage the best of both worlds. Trust in AI system grows exponentially when people know that a human can and will override a decision if needed. This is especially required in critical systems like healthcare and dealing with important financial transactions. So this is the flow chart. So without human in loop, if something is detected, an action is taken. With human in loop, if something is detected, it alerts the human. So an analyst takes an action on this. And we look at regulations and standards. The EU AI Act. This legislation classifies high-risk AI systems as those that have a significant impact on people's rights, such as those in finance and healthcare. It mandates that these systems must have human oversight. So this emphasizes or this puts us to a conclusion that AI will not completely take over all the jobs, because still AI needs human intervention in making critical decisions, and there are acts and policies where the companies to needs to adhere. So, but the kind of jobs are going to change, certainly. And the teams, there will be, the strength of the teams might decrease. Our colleagues might be AI agents or robots, but every one of us, it might be AI system or a robot or a human, should adhere to certain regulations and standards. So another one is NIST, AI Risk Management Framework. This framework encourages organizations to build audit checkpoints into their AI systems to ensure transparency and accountability. So the focus is on audits. RBI regulations from the Reserve Bank of India mandates that the bank must have clear appeal mechanisms for blocked accounts. We know we might have heard the terms ombudsman, RBI's ombudsman. There is a certain layer of appealing. If there is a problem with the bank itself, we have the if the bank is not responding with given time framework, we can appeal to RBI. So these regulations demonstrate that oversight is not just an ethical choice. Uh, it's a legal requirement. So we'll see the best practices. Finally, let's discuss some practical best practices for balancing autonomy and oversight. So set clear thresholds. For example, you can set rules that allow small transactions to be auto blocked, but any transaction over a certain amount automatically requires a human review. Build appeals mechanisms. Customer must and should always have a clear, easy way to challenge a AI decision. Train and analysts. The human analysts in the loop need to be trained not just on the technology, but on how and when to override an AI's decision. Responsible AI is not about AI alone. It's about a powerful combination of AI, humans, and a well-defined process. So to wrap up, I want to leave you with a financial, some kind of one final question. Say if your account is blocked by AI, don't you reserve to know why it is blocked? Suddenly we get a message that our account is blocked. So this links us perfectly to our next theme, transparency and explainability. So before going into that topic, let me take you to a couple of examples about autonomy in other contexts, like automated defensive responses, network intrusion. Imagine an AI system designed to detect and respond to network intrusions. A threat actor attempt DOS type of attack, DDoS, denial of service attack. By flooding the network with traffic from multiple IP addresses, they operating with full autonomy identifies this malicious traffic and automatically reconfigures network firewall to block those IP addresses. The technical detail here is that AI has the authority to directly issue commands to network infrastructure. Excuse me. So here, the detail here is components like routers and firewalls bypassing any human approval. The risk is that if the AI misclassifies legitimate traffic as malicious, it could shut down essential services, such as, mm, say, if we have a business e-commerce site. So if it shuts the e-commerce site during a peak business hour, imagine it's a business and financial loss and loss of trust. We might lose customers. So just another one practical example that we might be connected is, say there is some automated content moderation in social media. AI systems are often used to detect and remove malicious content such as hate speech or terrorism related material on social media platforms. The AI is given the authority to automatically delete posts on even and even suspend user accounts. We see that most of the YouTube channel owners might sometimes report that their accounts are being blocked. Many of the times it is not completely done by human user. It's not that a human is doing that. The based on some keywords, their content, some might be marked as bad content. So the ethical tension here is that an AI may not understand nonsense, the cultural context is bad or good. An innocent user's comment, some kind of ethical joke, positive joke, some satirical post, they could be misclassified and a result their account might be blocked permanently or suspended without any human interview. Leading loss of their digital voice, their community, their digital life, and eventually mm, their finance is related to their channel. So here, thing is, this can't be avoided at sometimes. In some cases like social media, where there are crores of accounts, but no, it can be done by humans, even the detection and action. But there should have at least appealing authorities. So that is one of the core idea. So here we'll concentrate on the transparency and explainability. Why the AI blocked me. Here the black box problem. No. The AI models make complex decisions. Customers and even the bank staff often they don't know why an action happened. So it's like a black box. Everything happens inside the system. No, just to understand the term, we watch the television, but imagine the television as a box. Most of us do not know what's inside the television actually. There will be some wires, circuits, cables, but on the high level we know. But how they're connected, what is the mechanism behind it receiving a signal, the digital signals, everything. So it's a technical thing. But what if in the TV itself, the hardware related decisions, like based on the power, based on the watts of the power, there is an AI system that it can easily shut down the TV, there is high voltage or something. It's doing so, but we might not understand the mechanism. The same way, there are systems, so many complex AI systems, but the staff itself might not understand. It's like a black box kind of thing. So this creates frustration, mistrust, and sometimes legal risk to the authority, particular organizations. So here in this case, the bank fraud detection example, the customers are told your account was flagged by AI. There is no explanation why my account is flagged, what what wrong I did. This creates helplessness. So so here the case, one example which we have seen earlier, a migrant worker in Dubai, say his salary is blocked because bank has detected some suspicious activity. So he'll be missing his rental payment or whatever the payments he is having, and there is no valid explanation given to him. So that is what explainability talks about. Risks of no explainability. So, it might create loss of trust. Customers leave the bank, and the AI is not accountable. So it is easy for the banks to blame the AI. So it violates the rights under GDP, rights to explanation. So these are the risks of explainability, no explainability. So here, black box AI versus explainable AI. So the black box AI, suspicious account blocked, no answer, that's it. But explainable AI, it's blocked. It says, no, it explains why we are blocked. In this case, it says blocked because called transactions, maybe continuous transactions or unusual time or flagged based on some international transaction. So it says, you know, of course, the risk score might not be, it might be the bank's internal policy, but for the AI, it's like the risk score is 89%. That's the reason it was blocked. So at least there is some explanation, and the user can respond that, yeah, it's my transaction is done outside the country, but because I'm abroad, so this is done by me. If he's doing say transactions, unusual transactions, it's like uh, he might be doing his monthly payments all the transactions after immediately receiving his salary on the first of the month. So there might be some 15 transactions that he might need. So at least he will understand, okay, this is the reason, this is the reason, and he can act accordingly. Say, for example, this we have spoken earlier, the credit scoring. We have applied for a loan, the loan denied. The customer should know. Uh, so here the regulations on the legal angle. We should be following the laws which are defined, GDPR, EU right, AI Act. So RBI and FATF guidelines. So every system must ensure that they have the corresponding answerable mechanism. So best practices for explainability. One minute. Okay. But I need to wrap up quickly as we are running out of time. Okay. So the best practices of explainability, like XAI technique, sharp line, explainable AI methods like shapely additive explanations and local interpretable model agnostic explanations, line. This allows us to peek inside, otherwise, no, otherwise it will be like a black box. These are explainable XAI techniques. And the other thing is provide clear reasons to customers. Technology insights must be translated into human understandable explanations. Instead of saying suspicious activity, the customer should see your account was flagged because of 12 unusual transactions from a foreign location within 24 hours. So what is a particular bank policy that has to be explained? That transparency reduces frustration, increases trust, and makes customers feel treated fairly. And appeal and readdress mechanisms. It's not only about appealing, it's again needs to be addressed by someone. Even with good explanations, AI can still be wrong. Therefore, organizations need a formal appeals process where customers can challenge the decisions, and a human analyst should review such appeals, override the AI if necessary, and feed that back in the model. So they should be retraining the model. This creates a feedback loop, better customer experiences, better data for future AI improvement, and adhering to stronger compliances. So here, this is a banking fix example. The example account blocked. So instead of account blocked, so we need to provide your transfer was flagged due to insufficient, due to unusual time or cross-border rules. So please verify and notify. That is how we might get some messages. Sometimes if we log in with our Google account from a different systems or a different place, we will be getting, is it you? Verify, such kind of things. So traditionally, when banks rely on opaque AI systems, the customer just sees the message, blunt message, account is blocked, no details, no options, just denial. This creates frustration, and mistrust, and even panic. But imagine if the bank took an explainable approach, saying the system could say, your transfer was flagged because it occurred at unusual time and involved cross-border rules. So this develops the trust cooperation compliance. So this takes us to the we'll quickly go to the next topic. What if AI makes a wrong call? Who is responsible? We will wrap in 5 to 10 minutes. Who is responsible? The algorithm, the bank, or the regulator? Who answers when AI gets wrong? The AI is not a legal entity, it can't be blamed. But its mistakes impact the real people. So someone must take responsibility. So it's very, very, very crucial thing. Like who is going to take the responsibility? The effects of AI mistakes are very real. A customer's account may be wrongly blocked. A family may struggle to access their money. A business might lose customers or face delays. A bank's reputation may be damaged if the public sees it as unfair or careless. So that creates a gap. The technology made a mistake, but the consequences fall on real people. Without accountability, victims are left with no clear path. So why? That's why accountability matters. So there are accountability frameworks are they are so important. Someone, whether it's bank that deployed the system, the vendor who built it, or regulators overseeing it, must step in and take responsibility. Otherwise, AI becomes a shield for blame shifting, where everyone says, it's not me, it's just an algorithm. It's the algorithm that did mistake. Sir,
Sir.
so can I take another, just make the conclusion in the next 5 minutes?
Okay,
Just
sir.
5
Carry
minutes.
on, sir.
Okay, thank you, sir. So we have seen this kind of example earlier. We'll quickly switch to the next slide again. So what is the real world and antidote? So the real world anecdote is like, say, for example, one use case. In Europe, several banks face lawsuits. We might not see this often in India, but in Europe, there are several cases. So several banks face lawsuits because their AI-driven fraud detection systems were unfairly blocking legitimate customer transactions. So what happened is customers were wrongly flagged as suspicious. Their accounts were frozen and they were unable to access their own money. Many of them suffered personal and business hardships, like not being able to pay rent, pay salaries to employees. So the legal fallout. These customers didn't just complain, they took the banks to courts. So they demanded compensation for the losses caused by wrongful blocks. So the court's key question here is, the courts didn't only ask, why did the AI make the decision? They asked the banks something more fundamental. Why was there no human review or safeguard before freezing someone's account? Why there is no human review before freezing someone's account? So, in other words, regulators and judges expect the human checks must remain in the loop, especially for life impacting decisions like finance, healthcare, or defense. So, the learning point here is the case highlights that blind reliance on AI is risky. Accountability isn't just about transparency, it's also about ensuring there are no, there, sorry, ensuring there is compulsory human oversight mechanisms in place. So this brings to fundamental, question. When A makes a wrong decision, who should face consequences? People who built it, people who used it, or no one? Either the developers, the users, or no one. So the data scientists and the engineers who designed the model, or the people like the banks, financial institutions, or the staff who relied on it, or no one at all. In the ethical lens, this is not just a legal or technical issue, but a moral question. AI is not a person. It cannot take blame. Humans designed it, deployed it, and choose to trust it, and humans are maintaining it. So, yet in many cases, victims feel they are fighting a ghost with no responsible party stepping forward. So it's like, if a doctor misdiagnoses, the hospital is accountable. If a pilots make a mistake, the airline is accountable. But if AI is making a wrong decision, who is accountable? So leaving the undefined creates the ethical unfairness and regulatory loopholes. So this is there are so many use cases of this, like who are impacting with the wrong decision, and like who is responsible. Say it's a AI-driven car, if something happens, who is responsible, kind of. So these are the again governance frameworks comes into play. So just a second. There is one final topic, but as we are running out of time, we'll just make the conclusion. So, AI in any kind of system, especially in cybersecurity, is powerful, but its future depends on the choices we make today. Like we have governance practices, regulatory frameworks, or even the broader and uh, ethical dilemmas and use cases we have touched upon. So this is everything depends on how we are adhering to that policies and building the systems. So yeah, thank you for your attention. Thank you, everyone.
Thank you, sir.
Thank you, Professor.
Thank you, Karthik sir. Thank you.
Okay, sir.
Uma
Uma
madam.
madam.
Thank you, sir. We extend our heartfelt thanks to you for delivering a highly informative and insightful sessions on ethical implications of AI and cybersecurity. And your expertise and clear explanations gave participants a deeper understanding of this critical domain and greatly enriched today's session, sir. Very thank you. And we are eager to engage with you again in future knowledge sharing opportunities, sir. Thank you, sir.
Thank you, ma'am. Thanks, everyone.
Thank you all.
Hello, sir. Can I end the meeting now, sir?
You can close the session.
Okay, sir.